Då tror jag kanske att alla börjar komma på plats, så att jag börjar så smått. Jag heter Ingrid Nordgren och jag är föreståndare för F3 och ansvarig för samverkansprogrammet förnybara drivmedel och system. Och jag hälsar er välkomna hit idag till dagens webbinarium där vi presenterar resultat från ett av våra forskningsprojekt som heter Implikationer av elektrifierande av kommunala transportsystem, regionala konsekvenser för produktion av biogas. Först lite praktiska frågor. Det här webbinariet kommer spelas in och kommer att finnas tillgängligt på F3s YouTube-kanal. Så vill ni inte synas på något sätt eller höras, så får ni låta bli att prata och ha kameran avstängd. Annars är våra riktlinjer så att håll era mikrofoner avstängda och kameran också, om det inte är så att du pratar eller vill ställa en fråga under diskussionsavsnittet i slutet sen. Och har ni problem med uppkopplingen, stäng av inkommande video. Ni får ju gärna ställa era frågor i chattfunktionen eller använda räck upp handen-funktionen. Men däremot så kommer vi inte svara på några frågor under själva projektpresentationen, utan de samlas till frågestunden. Och har ni några problem på något sätt, så kan ni försöka vända er till Emmy. Hon lägger ut sina kontaktuppgifter här i chatten också. Så hoppas vi att vi kan gemensamt försöka hjälpa er. Och presentationen kommer att läggas ut på våran webbplats efteråt. Ja, med det då så än en gång välkomna hit till dagens seminarium om projektet Implikationer av elektrifierande av kommunala transportsystem, regionala konsekvenser för produktion av biogas. Och vi ska få höra lite spännande projektresultat från det projektet som Michael berättar om sen. Mike kommer att prata engelska, jag pratar svenska som ni hör. Och jag kommer att inleda med att prata lite allmänt om samverkansprogrammet förnybara drivmedel och system som har finansierat det här forskningsprojektet. Och sen så avslutar vi med en frågestund på slutet där ni då kan ställa era frågor. Jag är ju då ansvarig för programkansliet för samverkansprogrammet förnybara drivmedel och system, och jag är också föreståndare för F3. Och vad är samverkansprogrammet då? Jo, det är ett forskningsprogram som drivs tillsammans av Energimyndigheten och F3, Svensk kunskapscenter om förnybara drivmedel. Forskningen som bedrivs inom programmet är systeminriktad och tvärvetenskaplig med fokus på förnybara drivmedel. Och det vi menar med förnybara drivmedel, det är biodrivmedel, förnybar el, vätgas, elektrobränslen. Och de frågeställningar som vi forskar om i det här forskningsprogrammet, det kan vara exempel som resurstillgångsfrågor, hållbarhet på olika drivmedel, olika produktionssystem och dess hållbarhet och ekonomi i jämförelse till varandra. Infrastruktur och infrastrukturs påverkan på den totalekonomin exempelvis. Det kan vara aktörsfrågor och styrmedelsfrågor som lite exempel. Och det finns ju i huvudsak 3 verktyg för att minska klimatpåverkan från våra transporter. Det är att effektivisera fordonen, minska transportbehovet och ha förnybara drivmedel för de transporter som vi ändå måste genomföra. Och det här forskningsprogrammet riktar in sig på det sista och tredje verktyget här, förnybara drivmedel. Så de andra frågorna är lika viktiga, men det är inte det som vi fokuserar på i det här forskningsprogrammet. Och tanken med den forskning och de forskningsresultat som kommer fram i det här programmet är att de ska underlätta att fatta rätt beslut för politiker, myndigheter och företag. Så forskningsresultaten ska fungera som beslutsunderlag. Det är det huvudsakliga syftet och önskemålet med det här forskningsprogrammet. Och lite fakta, mer i siffror. Vi är nu inne på slutet av den andra etappen av det här forskningsprogrammet. Den första etappen pågick 2014 till 2017. Budgeten för den här andra etappen är ungefär 47 miljoner i 26 stycken projekt. Av de här 47 miljonerna så är det 22 miljoner som Energimyndigheten finansierar och 11 miljoner som F3s parter finansierar. Och resterande övrig samfinansiering som medverkande i olika projekt finansierar. De flesta av er, eller jag räknar alla med er, känner till Energimyndigheten. Alla kanske inte känner till F3. Så jag tänker säga några korta ord om F3. F3 är en samverkan och nätverksorganisation för industri, högskolor, institut och myndigheter som tillsammans jobbar för en långsiktigt hållbar drivmedelsförsörjning till transportsektorn. Och det gör vi genom att bygga och sprida kunskap om förnybara drivmedel. Kunskapsbyggande gör vi då genom att finansiera och genomföra forskningsprojekt tillsammans med Energimyndigheten. Kunskapsspridandet gör vi genom att vi sprider de resultat och allmän kunskap som vi får fram bland F3s parter. Tillsammans både med Energimyndigheten då när det gäller spridandet av resultaten ifrån forskningsprogrammet. Men också tillsammans med Västra Götalandsregionen när det gäller kunskapsspridning lite mer allmänt då. Och sen så samverkar vi på olika sätt inom F3 men också med andra aktörer som jobbar inom det här området. Och de aktörer som är med i F3 det är 5 stycken högskolor, 3 stycken forskningsinstitut och ett antal industriföretag som då representerar både fordonstillverkare och drivmedelstillverkare. Och sen så är det Chalmers industriteknik som är värd för centrumbildningen. Och som jag sa då så samarbetar vi med Energimyndigheten och Västra Götalandsregionen. Så det var lite kort om F3. Jag vill också passa på att pusha för att vi har kommande resultatwebbinarier från fler spännande forskningsprojekt. De 2 närmsta som är planerade är den 14 september när vi tittar på jämförelse av olika drivmedel som är framställda av skogsrester. Och sen så har vi ett 5 oktober som handlar om hållbar HVO-produktion. Så håll utkik efter oss på sociala medier och på våran webbplats så kan ni anmäla er till de här om ni är intresserade av dem. Och anmäl er också gärna till vårt nyhetsbrev via våran webbplats så missar ni ingen av våra event som ni kan vara intresserade av. Så det var det jag tänkte säga om samverkansprogrammet. Och då har vi kommit till dagens presentation. Och det är Mike Martin som har varit projektledare som kommer ha presentationen här. Men han har gjort det här projektet tillsammans med flera av sina kollegor på IVL. Men också Filip Peck på Lunds universitet. Projektet avslutades i mars i år och har haft delfinansiering då förutom från Energimyndigheten och F3s parter från en mängd olika aktörer som ni ser här. Slutrapporten i sin helhet går att ladda ner på F3s webbplats Så gå in på våran hemsida och sen så kan ni antingen söka efter rapporten eller så kan ni gå in på samverkansprogramfliken så hittar ni den där. Så med det så vill jag önska Mike välkommen att börja presentera. Och now we will switch to English. So please share your presentation and you're welcome to start.
Thank you. Can you see this?
Yes, now I can see it.
Great. So thanks for the great introduction, and I'll present to you some findings from the research project that we had, which we like to call Electric Imp, or implications of electrification of municipal transport systems. So as a very short background, and I think most of you know this, we've started and many of us have researched about the development and expansion of, for example, biofuels and biogas systems that have taken a long time to develop. And what we see in recent years is that there's this, what some may refer to as a hype or rush for electrification, especially in the inner city municipal transport system. And this is promoted not only in Sweden, but worldwide. And what we see is that when they're looking towards electrification, what we often forget is that they're promoted with basically the same type of arguments as were promoted for example, biofuels or the incumbent systems that are in place now. And when there's electrification, there could be displacement or removal. And we see that there's some kind of tension in the industry right now, and that this leads to basically just talks of only the benefits of the electrification, but not necessarily these effects or the consequences that could happen in these regions or systems that are based on biofuels that were also again promoted as being sustainable and renewable, etc. So in this project, what we wanted to do is try and understand, for example, the implications and how do we actually model this? Because it's not necessarily easy to just say that it's climate friendly or something. We need to understand the whole system and how everything is connected. So with this, we had a lot of thought about how we wanted to do this originally and during the project. For example, when we wrote the application. And it was more about like the study and design and how would we do this actually, because it's quite a daunting challenge to understand this complexity in the system. So what we thought of and what we find unique in this project is that we first take qualitative information and study the discourse that's used to promote electrification. And what we do here is that we critically examine it to try to understand what do people talk about and what are the narratives that we find in this area. And this then gives rise to our next objective, where we try to understand what are the displacement effects. So what will happen, for example, when electrification comes, and how does this then, in the next objective, impact the environmental and socioeconomic system? So what are the implications? What are the impacts that this has? And finally, what are the political barriers and opportunities for electrification and displacement that we find? So we wanted to review these and then give an understanding so that we can spread a bit more knowledge about it. And if we start, for example, with some findings before you see basically how we did this, what we come to is that the discourse it's very powerful. And what we find is that media is very powerful to basically spread this almost homogeneous message that electrification is generally very positive and that it'll lead to a better system. It's the future. It's the best system for us in the future. And that gives rise to the next parts of our study, because what we find is that we need to be able to understand actually how to model this, because much of the discourse that we find is very basic, and it talks about only direct implications of switching from this to that. So we then did the modeling, and we found that overall there were, of course, the discourse was quite right. In the end, the direct benefits are very profound, and we see that the electrification of inner city can directly benefit a large number of things. So we developed the model, and we found that the greenhouse gases, for example, the emissions, and the socioeconomic impacts of reduced exposure to these emissions, etc., are all improved. But what most studies often don't take into account are the indirect benefits of if we move these systems, or if we take the biogas and we put it in new markets. And that's where we found a large share of the benefits from the system. And if those aren't taken into account, we could possibly lose the sight that the biogas systems are important and valuable. We also came from the policy study. We came up with some ideas on incentives and suggestions on how to promote the displacement for biogas in new markets, and how it can be promoted more general, which I'll come back to. But I think that the findings are also very relevant for a number of different areas. But it's very important to understand that what I'm talking about today is based on the Stockholm context. So we modeled this based on Stockholm, which is primarily a wastewater treatment plant based biogas system. And it might not be exactly generalizable to other areas where there's, for example, co-digestion, etc. But the input that we have is very interesting, and it can be used for decisions. And we see this as basically a beginning for other studies. And I'll bring this up later, but we're also developing this further. So it's not just a study that's been done and it's just set on a bookshelf. We're actually developing this, and there's a lot of more things coming. So to give you a little bit more information about the method. So how we did this was that we took a 4-step approach, where work package 1, the discourse and content analysis, was input to the development or a mapping of the consequences in what we use, and we use causal loops for this. And this information was then used in a system dynamic model. We also used the stakeholder dialogue to validate and give input to these causal loops and the system dynamics. If we look more in detail, it looks a bit like this. We look through the discourse, we find the causal loops, we do the system modeling, and the policy lab gives input to the second and third. And I give these numbers as well so that you can follow a bit where I am in the method. What's also important to note is that what we kind of want to make apparent is that this was primarily a method development project. And we wanted to develop an approach to study the regional implications of decisions so that we can then develop this and use it for further assessments. And we used the same method in a large number of different projects at IVL. So the first part of it is the discourse, so the number 1. And what we did here is we basically took a lot of media, so news articles, trade and branch journals, independent reports, governmental and policy documents, and even interviews. And we took these and we used a program called In Vivo, and we studied the discourse, the content, the narratives, we coded. We did a lot of qualitative research methods to understand what is it that they actually talk about. So with this, we can then find the expectations created, how they envision future systems, the benefits, the drawbacks, and if they even talk about displacement effects. And this, we had a large number. So there are, for example, 231 news articles, 83 journals, etc., and a large number of interviews. So there was a lot of empirical data here, which then led to some really interesting outputs. But what we found overall, and I don't think that this is entirely new is that we have this electrification of all inner city fleets. This is our main possible future that we find. So these were overwhelmingly highlighted in most of the media that we found here. And basically that electrification is the future and all inner city fleets will electrify. But the other narratives that we found that kind of sprinkled a little bit in and that came from some more biogas proponents were that biogas and other clean fuels could be actually, like we call, displaced to peri-urban and regional traffic, so that we have biogas still in the system. A third possible future talks about biogas and electric synergy, so that they can be similar like filling stations in different areas, but also that biogas will continue to play a role in the energy system. But above all, I think what I highlighted and underlined here is that electrification of all inner city fleets is the thing that we focus mostly on in this project. If we look a bit more at the discourse that or the discourse analysis, we want to know what did they actually say. So first of all, we found the narratives and like I just showed, the potential futures. But what most of the studies talked about, they were basically motivating electrification based on the environmental benefits and socioeconomic benefits of the system. A lot of them were articles and descriptions of being the biggest, the best, and the first system. So there's competition between the different regions on who is the best and biggest and who can have the most buses, etc. So we thought that this was really interesting, but also like the technology and this is new and we're going to use the latest from Volvo or Scania. But also, again, like justifications, and they want to provide better environment for the people and basically responsible stewardship for the travelers. But the discourse didn't only stop there, because there's so much empirical data that we have there that we could use it for different ways. And another way that we looked at is we wanted to see what are the salient environmental and socioeconomic aspects. And this was really important for the modeling, because most of the previous studies that we find, they focus only on maybe one or two indicators of, for example, electrification. And what we wanted to see, what are people talking about, and do they have information to back this up? So we didn't find too much backing up of the information, but we did see a lot of discussion about, for example, clean, particle-free. Noise was a big one that was often highlighted as being very relevant for electric buses. Carbon dioxide emissions, it's energy efficient, fossil-free, etc. So we took these and we could then use them in our modeling. And this is where we then took these possible futures and we put them into the causal loops with input from the policy lab you see above. And this section we call the mapping of the consequences. So what we do here is we basically build scenarios, but it's not a typical scenario building where we look at, for example, best and worst case or technical feasibility or something like that. What we try to do in the system is look at dynamics and how things are connected, because things don't necessarily are 1 and 0 or plus or minus. We see that they interconnect. So they have causation or and they have a negative and positive effect on each other. And it kind of looks like this. So for the increase in electric bus fleet, we see that there's positive and negative impacts on other systems. And that has important implications on the system as a whole. So it then affects, for example, emissions, socioeconomic indicators, and then we need to figure out how do we model this based on that. And then this is where we came to we took that information from the causal loops and we developed system dynamic models. And in this, again, what we're trying to look at is we're not seeing this as a static system, but over time. we modeled, for example, the Stockholm electrification for a 30-year period. And it's very dynamic, and there's a lot of decisions along the way. For example, the procurement period and when the buses will come, etc., that'll affect when the impacts happen and how much impact it has during those different periods of time. So what we try to do with the system dynamic model is understand the dynamic nature, but also see what are the different outcomes, and again, model these environmental and socioeconomic implications that we came up with from the discourse. And sorry, in this picture here, it shows, for example, direct and indirect. So the inner circle would be like direct impacts in the inner city, and the outer ones are like the influence of external or indirect factors. It might be a little difficult to see, but this is what it looks like in the system dynamic model. So we have stocks and flows of different systems, and we can add factors and different functions in all of the different things here, and we can set the time periods. It's really quite powerful, and it's honestly quite boring to show because it's just these little pictures like this, and we can make it a little more visually appealing in the next round of this study. But we can study how things affect each other over time and how they're linked, as you see here, the arrows in between the different systems. And this is only the main module, and there's other modules that connect to this. In the overall results, what we found is basically the overall output of this project. What we want to stress is that we came up with this approach to be able to model and develop and expand it. So we can see that from the Stockholm system, we had a system that we know is going to change to electrification. And we can see, for example, what is it that's going to happen? How do we model it? And how can we add the factors in? And this is very important because then we can use it in the next iterations of the project. But overall, what we did find is that we had extensive reductions in greenhouse gas emissions in the inner city, but also an indirect from the displacement of the biogas to new markets. But in the inner city, of course, we had particulate matter reductions, which were very significant, and nitrous oxide emissions, which then also led to socioeconomic cost savings. And this was to reduce exposure to, for example, CO2, PM25, and nitrous oxide. And if you remember, for example, the electric buses were often promoted as being less noisy. We didn't find this from our research that it was a major implication for this. It only had a minor reduction, but then those also added to the socioeconomic costs savings, because reduced noise also leads to a better environment for working, etc. And this then also, we looked at employment systems. So from the electrification, we could see, for example, that we could increase employment in a large number of areas by using the different buses and shifting the biogas to new areas. And once again, the displacement, I think, was a major importance in this study. When we displace biogas from the inner city, we need to find new ways to use it. In our study, we looked at using it in heavy vehicles outside of the city. And this led to very large improvements of greenhouse gases and other emissions. And finally, we come back to the policy lab, which again gave input or validation for the closed loop diagrams. And with this part of the project, what we did is we had a series of workshops where we engaged with actors to discuss basically how we could develop incentives and what is the current state of the biogas system, etc. And with this, we did a couple really cool workshops, and we came up with different ideas on recommendations to support the displacement of biogas, because we were kind of all under the same impression that inner city transportation is going to be electrified. So what happens and how do we support biogas so that it's not lost? And this was outlined in a policy brief, which you see here, ge biogasen nya förutsättningar att utvecklas där. And you'll find the recommendations here, which is basically, again, focused on how biogas can be supported for the displacement to remain a viable solution. And with that, the overall, from the study, I would say that the main conclusions that we found are that the discourse is very powerful, and the media is very powerful for motivating change. So we found that lots of different media, they say basically the same thing. And this then promotes the systems, and it leads to other areas understanding that this is good. And we don't see much critique of this. So it's throughout the discourse, we see that there's a main focus. And I think that it's really powerful because it can actually then go up to decision makers. And what we need is a bit more quantitative input and the studies like this to provide some background on whether or not it is good or not. But what we did find, luckily, is that the electrification was very, very well placed, and it validated a lot of the discourse that we found that it's going to be good for the direct system. But I think that something that's very important is that we found that, again, that if biogas is shifted to a new market, it's of significant value and it should be kept, because that is a very large part of the overall benefit from the system. So with the results that we came up with, we could say that we provide some information on how, where, what, and when, basically, to improve, implement, and intervene to promote the different systems, both electrification and biogas, so that we can promote sustainable energy systems for transportation. Again, I want to take the chance to say that this is an expanding or living model, that we would like to call it, because we're taking the learnings from this project where we learned a lot. And I think that's one of the main things that I take away also from the project, is that we had these ideas about the method and how we would do it. And as usual, it doesn't end up exactly like you think, but we made a lot of really cool advances, and we have this model that we can expand and iterate. And we're going to do this through the next, what I talked about before. We're going to do this through the next study that where we're currently developing a model for the Skåne region, because this is very important. Again, since Stockholm is a wastewater treatment based one, and we wanted to look at a co-digestion based system. So again, the results, especially from this output, are quite context dependent on Stockholm. So not everything is generalizable to other areas in Sweden, although it does concur with a lot of different studies in Sweden on electrification and biogas interplay. And with that, I think that I didn't show too many details on, for example, the results. And that was on purpose, because there's a large empirical and quantitative output that was outlined in the report. And these are somewhat complex. So if you want to nerd out and get more information about the details on the method or the dynamic results, how we made things, the graphs, deeper understanding of the project, basically, you can find it in the overall report. And if you're interested in the recommendations that we had, we also have the policy brief, and both of them are available on the F3 site or on the project site and through IVL. And we're also developing a scientific article that should be published. And yeah, we're happy to answer any questions and answer anything or comment on anything if you have more suggestions or output or suggestions on how we could do this in different regions, etc. Thank you.
Oh, thank you very much, Mike. So now it's open for questions for anyone here. If you just raise your hand or write your question in the chat function, and then you can ask it in Swedish as well. Maybe Mike answers in English, but it's fine if you want to ask your question in Swedish too. So while you are considering if you have any questions, I have some. First, if you, Mike, now maybe this is not exactly what you have studied, but if you are now working at a public transport company or a region, and you are standing in front of this question, should we electrify the inner city buses or should we keep our biogas fleet that we have? What would you do, or what would your recommendation for them be? How they would handle the situation?
Yeah, I think you need to take into account like a holistic perspective, and I think one thing that we didn't cover as well is the investment costs that'll require as well for these type of systems. So how hard is it to switch, and how efficient is it right away and in the future? How do you count all your apples now and put them in one place and say we're electrifying all, or we're doing it successively? I think the better approach would be successively, since it will you'll get better vehicles in 10 years that are more efficient, and hopefully we work out some of the issues with, for example, battery recycling, etc.
But your recommendation would still be that at least, gradually transfer to electrification in the inner city.
Yeah. And also maybe, since they're often separate entities, for example, the production of biogas and the regional transportation actors, maybe also help to promote the use of the biogas in other displaced markets, because that's often forgotten, and we only focus on the benefits that directly occur. Yeah. But we forget about this incumbent system that we had that was actually could be good overall as well.
Yeah, because that's I have two questions regarding the biogas then, because one is what in the places in Sweden where you already have this transition, where you have moved from biogas to electrification, what has happened with the biogas? Are they what do they do? Has it decreased the biogas production in the region, or what has happened? Do you know?
Yeah, in some areas they're very scared, I would say, about what will happen with it. So for now, there's still a good market, but I think in the future it's uncertain what will happen with it. And I think that's what we've heard it for a long time about incentives and this långsiktighet for biogas support. And I think, but there is some promising input as well, because we see, at least I follow on LinkedIn these. I'm not necessarily a biogas proponent or anything, but I see these things happening all the time, where all of these big åkeri and companies are switching to biogas transportation for example, longer distances. And I think that's one area where it can go. But if you're a biogas producer that's reliant on a market in your region, it's a difficult issue to deal with. And that's why we came up with some of these suggestions on incentives and helping to promote it in new areas.
Yeah, because that's my personal reflection from this is that that's really the key here is to create a new market for the biogas, because basically you're replacing one good thing with another good thing, and then the good thing that is now not used anymore, you have to use it in another good place, so to say.
Yeah.
So.
And you want to continue with those benefits that it provides, biogas.
Yeah.
And like I suggested in this study, the benefits might be totally different in Stockholm or in Linköping or in Skåne or in Gothenburg, etc., based on what they use to produce the biogas. So that's one of the main outputs that can be changed in such models, etc.
I see that Philip Peck, one of your co-workers on this project, raised his hand. So Philip, please turn on your camera and
the camera too. Yes. And look, I just thought I'd toss in one. Forgive me, I can do it in Swedish, but it probably comes out faster and more time effectively in English. One thing that we didn't take up there is the difficulty for regional decision makers, because for decades they've been investing in biogas systems, and the benefits actually accrue to society and to the climate and to the general areas. It's very difficult to pin down direct benefits unless you look at, for example, reduction of leachate to groundwater in agricultural areas, and the circling of manure in agricultural systems. Otherwise, you're doing this for the good of the planet and to meet climate goals, and all of a sudden the shining new solution comes up where it's very tangible for the people that live in your city. They saw buses that said biogas, but they felt no different from a diesel biogas, and now they have a new solution. So there's also this issue of we've been subsidizing the greater good. Now we invest in a new functional system for the city, and people can really see a change. And so that's a tough political situation to be in at the local level, and they do see lots of advantages with the cost-effective delivery of transportation with the electrical system, and so that's something that we can't forget. And so all of Mike's points about the greater good, the environmental benefit, the broader socioeconomic benefits of the biogas system, they're lost to Sweden. The effects on Stockholm or on Malmö would be quite different.
Yeah, thank you, Philip. Any more questions or comments from someone in the audience? You talked about the next step here when it comes to looking at different regions. So that's basically your further work, or are you also looking into development of the model in different ways, or yeah, can you talk a little bit about the next step?
Yeah, I think that's a really good question, because maybe I didn't go into too much detail, but the models are we were a bit adamant with our method, and we wanted to stick to our method, and we wanted to say, like, this is how we did it, and this is how we came up with it, and we'll model it based on that input. But that also gives some limitations on what we could have done, which we also discussed in the report. But it's that's actually quite interesting, because we can see that there's a lot of other factors that could be involved here, which I showed in this big circle diagram as well, like the cost of natural gas, etc. And those can influence a lot on what is actually purchased and how the electrification comes over time, and what happens with the biogas. So we have a lot of different ideas on where we can add factors that can actually change during this dynamic period. but also, for example, what we come up with, the indicators. So we showed, for example, I think we had 5 indicators. We had greenhouse gases, nitrous oxide, particulate matter, noise, jobs, and 6 socioeconomic costs. But we had a lot of other indicators that we could also include. Oh, sorry, and noise. But we couldn't find the best data to be able to model those. But those are also developing, so we can add some new ones in. And we see a lot of studies coming out, even during when we did this project, that are not necessarily similar, but have a similar background. So we can all also discuss and see what we can use. So I think that what we'll do with that one is we'll also change the biogas model, because for the Skåne system, it's a lot of co-digestion, and that will need to include agriculture and other things that Philip was talking about. So it's a bit more complex, but that's fun as well.
Yeah. And then I was thinking about these 8 recommendations that you just showed the front page, basically. Could you mention some things about that? I think I'm thinking about especially this how to promote the use of biomass in other systems. Just some brief examples of these recommendations.
Yeah, I have a slide with those actually.
Yeah.
I kept them towards the end if someone asked.
Yeah,
so
there it is. Yes.
Yeah, so you can see so they're basically about influencing EU regulations, for example, on climate impacts when you calculate them for biogas. I think that this goes along with a lot of my previous research as well, that you shouldn't only look at climate change as of course it's very important and it's one thing that we need to focus on, but for biogas that doesn't necessarily encompass all of the benefits that it is included for biogas systems. So you need to look at more there, but also maybe, for example, with negative carbon emissions, for example, when we talk about manure and different things there, so consequential modeling, giving incentives for new markets as they develop, because that's very important for the use of biogas, but also like helping the not only the markets but also the users to promote it. So private and offentlig sector, and also like through public procurement. I think that's one thing that's I didn't get too much into, and there's been projects about that before in F3, that procurement is a very powerful tool for the purchase of the fuels. And there's like this gray zone on what is, you're not allowed to be promoting one system, but you can do it through this like energy efficient thing for electrification. But that's one thing that we talked a bit about. Yeah, and basically give examples and show what's being done. I think that was the last points here, that it's important to show those and so people know. Because one thing that we found is that a lot of times there's a lot of talk about the benefits and things that accrue for biogas systems, but there's very few studies about what those benefits actually are. Or they might say there's socioeconomic benefits, but there's not that many people who actually do a study on those socioeconomic benefits. So we also need more studies there. So I would promote further studies as well.
Yeah, and that's also, I mean, I think this policy brief that you have made is excellent. I think it's a really good one, but it's, I mean, the target group here are politicians and the decisions maker in that respect as politicians. But for example, in the research society or within a group of academia like ours in F3 and the samverkansprogrammet, what could we do in your perspective to help in this transformation? A difficult question.
I mean, personally, I would say to stop focusing only on carbon dioxide as an indicator for the sustainability of a system. We see the biogas is an important example, and I think that the models and different things need to be expanded so that you can include that. And that was one thing that we tried to address with this project as well, that we develop new approaches for doing scenarios and indicators.
I think Philip has a comment again. So please go ahead, Philip.
Yes, addressing your question about what could F3 do. A few years ago, both Mike and I were involved in another report where, as an addendum, we threw together a very long summary of different studies that had looked at the socioeconomic spin-offs of biofuel systems. And in Sweden, when there was a big upswing in biogas, the RAPS model of Sweden was used. And to an outsider, there is a model that has updated databases for Sweden, but there seem to be very, very few people who can use those models. And if you look at the Biogas Öst and andra rapporter för typ 5 år sedan på biogassidan, you will see how powerful they are at counting the broader benefits of systems like that. And so one thing that F3 could do is to push and find out what resources and what training and how many users of that regional economic growth model are actually out there, because when we did our study, it seemed that the only people able to do that were actually placed in consultancies. And so that's a big gap in the whole renewable fuels and branch, and that goes directly back to Mike's comment that we have to count more than climate gases. And there are some good examples of how it's been done in the past.
Yeah, that's very true. But then also you come to when you take all, I mean, different benefits or nackdelar into account, then you come to the question of how to what you say in English, how do you compare them, and how do you evaluate them in respect to each other? That's also an interesting topic, I think. So let's see if we have any more. Today it's only me who asks questions, so don't feel afraid to ask any questions, anyone, if you want to say something.
And in Swedish is fine.
Yeah. Gärna på svenska. Ni får gärna ställa frågor på svenska också. Ska vi se. Annars I don't think I have any more questions. So. Okay. So maybe we should round it up there if no one else has any questions. Thank you very much, Mike, for a very interesting presentation and a very interesting project. I think this highlighting this system where, as I put it very simple, one good thing replaces another good thing, is very interesting. So please join us on our website and sign up for our newsletter. And thank you very much, Mike, and everyone for listening today. Thank you.
Thank you.